Hello everyone and good to have you join us in today's class. So today we continue from where we stopped in our last class. So in our last class we started solving chemistry work past question on the topic chemical equilibrium and we continue from there today. So for the first question we have here, in an endothermic reaction, which of the following will favor the formation of more products at equilibrium? A says decreasing temperature, B says increasing temperature, C says decreasing pressure, and D says adding a catalyst. The correct answer here is option B, which is increasing temperature. For an endothermic reaction, it is absorbed as a reactant. According to the Chantellian's principle, increasing the temperature adds more heat, which shifts the equilibrium towards the right, that is towards the product. This is because so as to absorb the additional heat. Option A is incorrect because decreasing the temperature would shift the equilibrium to the left, and option C and D do not directly affect the temperature. Decreasing pressure can only shift the equilibrium if the number of mole of gas on each side are different, and catalysts do not change the equilibrium position. So hence, our correct answer remains option B, which is increasing temperature. Now we run through some theory questions on this topic. For the first question we have here, it says, define chemical equilibrium and explain the concept of dynamic equilibrium in a reversible reaction. So for the first part, chemical equilibrium refers to the state in a reverse chemical reaction where the rate of the forward reaction equals the rate of the reverse reaction. This results in no net change in the concentration of the reactant and product over time. This does not mean that the reaction stops, but both the forward and the reverse reaction continue to occur simultaneously. As for the second part, dynamic equilibrium is the term used to describe this condition because at equilibrium, the molecule continue to react, but since the rates are equal, the concentration remains constant. It is dynamic because the reaction are still happening, unlike static equilibrium where no reaction occur. Now let's look at another question. For the equilibrium system below, here we have 1 mole of nitrogen gas reacting with 3 mole of hydrogen gas, giving us 2 mole of ammonia. We are asked to explain the effect of increasing the concentration of hydrogen gas on the equilibrium position. So according to Le Chatelier's principle, if the concentration of one of the reactants in an equilibrium system is increased, the system will adjust to counteract that change by consuming the added reactant. In this case, increasing the concentration of hydrogen gas will shift the equilibrium to the right, thereby favoring the forward reaction and leading to the production of more ammonia. This occurs because the system tries to reduce the concentration of hydrogen gas by forming more ammonia. Lastly, explain how a decrease in temperature affects the equilibrium position of the following exothermic reaction. So we have 2 mole of sulfur 4 oxide reacting with 1 mole of oxygen gas, giving us 1 mole of sulfur 6 oxide. So in an exothermic reaction, it is released as a product. So according to Le Chatelier's principle, decreasing the temperature will shift the equilibrium towards the right, thereby favoring the formation of more sulfur 6 oxide. This is because the system tries to produce more heat to counteract the temperature decrease, and the production of sulfur 6 oxide releases heat. Thus, lowering the temperature favors the forward reaction. So we have come to the end of this topic, and in our next class we'll be looking at another topic, which is hydrocarbon.